To set up your notes for today, go to the appropriate page on your IP side and title your notes Elements and Compounds. The essential question for today, I want you to compare and contrast elements and compounds, meaning compare their definitions, their properties, and their symbols. And by compare and contrast, that means at the end of your notes, I want you to be able to tell me how they're the same and how they're different. So pause this video as long as you need in order to set up your notes, and here we go. This is the first section of your notes. This is all going to be about the elements. A lot of the stuff you already know, but here's the official definition of an element. An element is a pure substance made of one type of atom. For example, pure gold. We already learned about gold from the periodic table. The symbol is AU. And if we had pure gold coins, it means we would only have gold atoms. And another fact about elements is that you cannot break it down because it's already in its simplest form. Like if you took that gold coin and you cut it in half, you would still only have gold atoms. You might be able to separate out even one atom, but you would still have a gold atom. So elements are pure substances made of one type of atom. Gold is an example, and it cannot be broken down in its because it's already in its most simple form. I especially want you to take note of the examples, but also to draw this picture and color it. Because if I were to sketch just an example or a diagram of an element, it would be a substance where the dots or whatever is inside, the particles, are all the same thing. Highlight important things in these notes and write a question about an element. Here's section 2. This is also about elements. You know this part already, but we're just going to review it some more, that there are over 100 elements and they're found in the periodic table. Now, when you're looking at elements and you only see the symbols, you know something is an element because it only has one, the symbol may have one or two letters, but only one uppercase letter, like C is for carbon. And even though helium has two letters in its symbol, there's only one uppercase letter. Same thing for aluminum. This is a lowercase L, not an I. And so since there's one uppercase letter, that means that this is one atom or one element for the element aluminum. Highlight and write a question about the elements and how you know that something is an element just by looking at the symbol. Section 3, compound. A compound is also a pure substance, but it's made up of one type of molecule. Now, if you think back, we remember that a molecule is something that is two or more atoms chemically combined together. So another definition of a compound is that it's two or more different elements that have been chemically combined. Here's the key. Chemically combined, meaning you can't break them apart now. So salt is a great example. You can have pure salt, and salt is a compound. It has sodium and chlorine that make up the compound. Two different atoms, but this right here is one molecule of sodium chloride. Pure water can also be is also a compound. It can be pure, but it has different atoms in it. It has hydrogen and oxygen atoms to make one water molecule. Therefore, since it's a molecule, then it is considered a compound. The way that you can tell the difference between an element and a compound based on the symbol is that in a compound, the symbols will have two or more uppercase letters. Just like this one right here, salt, Na, one uppercase letter, Cl, another uppercase letter, meaning that this has one atom of sodium and one atom of chlorine, but they're chemically bonded to make a molecule. Same thing with water. Uppercase letter, this must be a compound, two atoms chemically combined together to make a molecule. And there's millions of compounds in our universe. So if we think back to our last slide, there's only about 100 different elements that are found on the periodic table, but there are millions and millions of combinations of them that make compounds in our universe. Make sure you write a question about the compound because here comes section 4. Also about compounds. Here's something really important you need to know about compounds. Compounds cannot be separated by physical means. Since they are combined chemically, they can only be separated chemically. Let me explain that. Hydrogen and oxygen chemically combine to form a water molecule. Now, I cannot separate that molecule by physical means. That means with my physical body. Now, I might even be able to take out one water molecule from the whole bunch, but once the oxygen and hydrogen are chemically bonded, I can't do anything to separate them by just using physical means. Since they're combined chemically, they can only be separated chemically. There is actually a way to separate the oxygen and hydrogen through a process called electrolysis, but that has to be done with special chemicals and special equipment in a lab. So we would say that water can be separated, but only it can be separated chemically. I can't just do it with my physical body. Here's something else really important you need to know about compounds. I don't know what you need to do, highlight, box it, circle it, whatever, star it. You need to know this about compounds. The compound properties are completely different than the properties of the individual elements. Let me explain. Hydrogen is a gas that's flammable. Oxygen is also a gas, but when they combine chemically, they turn into something completely different. The properties of water are completely different than the properties of hydrogen and oxygen when they're by themselves. Here's another example. What we've talked about before. Sodium is a silver, explosive, reactive, soft metal. Chlorine is a green, poisonous gas, and yet when they chemically combine together, they make table salt, which is something completely different, meaning showing us that the properties of the compound are totally different than the individual elements once they get combined chemically. Here's another example. Iron all by itself is a gray hard metal that's magnetic. This is an element, one uppercase letter. Sulfur, I've showed you before. Sulfur is a soft non-metal solid that's yellow. Sulfur is an element. But when these two are chemically combined, they make something called iron sulfide. And I can tell this is a compound by the symbols because there's two uppercase letters. And iron sulfide is a black non-magnetic solid. So all of a sudden it becomes non-magnetic, where it was magnetic before, and it's black, not gray, and not yellow, because the properties of this compound are now totally different than the properties of the individual elements. So this is it for your notes. Here's what you need to do now. Make sure that you highlight important facts. Any pictures that you have, you've colored, that you write 4 questions, 1 for each section, and that you have at least a 4-sentence answer to answer the essential question.